Good afternoon, everybody, and thank you for being here. And I would like to thank LHP for giving us this opportunity to learn and develop our skills. So, a little bit about myself. I have a master's in electrical engineering from Stony Brook University. I graduated in December. During my master's, I have 2 years of project experience using machine learning and deep learning. I joined LHP to use these skills. Also, during my bachelor's, I worked as a COO for 3 years in my family business. So I developed management skills and other business development skills over there. In this presentation, we'll go through some things which we learned in the course, such as Agile, ROS, SONAR, Camera, LIDAR, Y Fusion, Future Work, and Conclusion. So during our first week, we were introduced to the Agile Manifesto and Scrum. I really try to use the Agile Manifesto and the principles whenever I can throughout the course. The two most important principles I used were welcome changing requirements and deliver working software frequently. So all my codes are written in a function basis. So at the end of each day, even if the whole program was not ready, some of the functions were ready. And each day there was a software or part of the code which was running. Along with that, changing requirements. So currently we are using a 2D LIDAR. So my algorithm works for a 2D LIDAR, but by just making few changes in the code, we can make it work with the 3D LIDAR so that we don't have to write the whole algorithm again. So ROS. ROS is an open source. We use ROS for our robots. It is a meta operating system for the robot. What it allows us to do is test our developed features correctly in a safe environment, basically, and help finding flaws in the algorithm. So the first sensor we used was SONAR. The main important part here is checking the range, which is 2 centimeters up to 4 meters. So this is not a very accurate sensor. It gives good values only in this range. Above 4 meters, it doesn't work. So the applications I developed using the SONAR were park assist, collision prevention, and blind spot detection. Here's an example how the blind spot detection works. So the sensor is faced at the side view mirror, where it is facing the other lanes, the lanes which are not in the view of the rear view mirror. And if an object is detected, if a car is detected, it blinks the light or it rings our alarm, whatever we want it to do. Next, we used a camera. So for camera, the field of view is 60 degrees. So the applications developed using camera are lane detection, object detection, and classification. Here's an example how the lane detection and lane following is working. It also helps us give us a lane departure warning. Here's how the internal algorithm is working. So first, the stop sign is detected. After that, the stop sign is marked. Similarly, for the lanes, these yellow lanes are detected and these pink lines are drawn by the algorithm itself. And using these pink lines, the steering angle is calculated and sent directly to the wheels. Everything here is autonomous, basically. Nothing is pre-calculated. Next, we use the LIDAR, whose range is from 15 centimeters up to 12 meters and a precision of less than 0.5 millimeters. So this is a very accurate sensor. The only drawback we have is that it is a 2D LIDAR, so any object which is not in its line of sight won't be detected. I'm really proud of my algorithm for LIDAR. It is a good achievement that I did at LHP. So how this works is our bot is 27 centimeters wide. And if there's a window of 40 centimeters, the bot can go through it. So I decided the window should be 40 centimeters and at least 50 centimeters away, that is the height of the triangle. So at least 50 centimeters away, it should decide whether it can go through that or not. So using simple trigonometry, I decided the angle, which was 40 degrees. As long as there are no objects in this triangle, this window will exist and the bot can go through. So here's a good example. All these objects are actually out of this 50 centimeters range. The LiDAR could have chosen this part, this, or this one. But it chose this part because it sees up to 12 meters. So the algorithm is actually calculating the best path, not at that moment, but like it can see up to 12 meters, as I said. So in the long duration, what would be the best route for it? So after this, angle is calculated, it is sent directly to the wheels. So that was one of the challenges, getting the correct turning angles. Okay, fine, I've got the angle from LIDAR. How do I pass it to the wheels? So for this, I implemented a PI controller where these angles from LIDAR are ratioed and changed according to the turning angles of the wheel. Also, getting the correct window size was really important, whether it should be 40 centimeters or 30 or 50, we didn't know. So to get the correct window size for our track, the technical way would have been to develop a simulation using Gazebo, which would have taken at least 2 hours. But we found a simple way. I took the help of my teammate Sai. We went to the track. We literally just used an inch tape or a measuring tape and a few rulers. So we got a rough estimate of the angle and the bot works well. Also, the time complexity here is really important. Time complexity basically is how well the algorithm works, how fast the algorithm is. So the current time complexity of the algorithm is O of n, which is fast, I would say. So when we are using a 3D LiDAR, the data points will increase from 360 to around 12,000. So if the time complexity is bad, then the algorithm will be slow and we won't be able to use that data properly. Here's the video of LiDAR, how it is working. It finds the best part automatically and just follows it. So fusion, as Sai indicated, why fusion is required, because measuring distance from the camera is not an easy job and it's not accurate. So now we have a LiDAR. LiDAR can measure the distances. So we use the LiDAR and camera to detect the object using camera, following the lanes using the camera, and the LiDAR measures the distance of the object. So the application is developed for lane change assist and path planning. Here's how it works. So the car was following this lane. As soon as it detects another object, it switches lane and it starts following the other lane. If there were no lanes on the left side, the car would have just stopped. So the challenges faced while the fusion were the field of view of the camera and bot did not match up. Also, we are using a 2D LiDAR, so the camera height and the LiDAR should have matched perfectly. Otherwise, object detection would have been a little more difficult. So when I place the camera parallel to the floor, it has a dead zone of 60 centimeters. With respect to the car, it's a lot. But in a real world scenario, 60 centimeters is nothing because the hood of the car will cover up that space. So for this, we tilted the angles and we prevented the car from turning earlier than needed. After this future work, I would say is I would like to work more on radar and GPS. And I have a couple of algorithms in mind, which would be adaptive focus control, which would work as radar can see much further than anything and it can measure the speed of other objects. We can develop an algorithm which would judge the speed of other objects and change our car speed. Also, using GPS localization can be done really well, which will help in our fusion case, as lane change assist and other things will work even better. So concluding, we have developed these ADAS features such as lane detection, blind spot detection, prevention, path planning, lane change assist, and park assist throughout the course. Also during the training, I've improved on my skills such as teamwork, time management, communication, critical thinking, and analysis. So whenever I used to think of an algorithm, I always used to pitch up to my TA, Elsa, and teammates and other interns around here. And I used to get their view of what they think about the algorithm. This helped me finding flaws in the algorithm before I implemented it, so that it is perfect when it is implemented. And it helped me explain things better to them. So any questions for us?